It's midnight, and Ron is peacefully lost in dreams. Suddenly, the loud sound of his cell phone ring disrupts the silence. It's the operator from the plant where Ron serves as an automation tech. The urgency in the operator's voice tells Ron that something is not right. The plant is down and they need his expertise urgently. In a rush, Ron arrives at the site and hurries to the control room. Ron opens the control cabinet. A red light on the PLC processor blinks ominously. A major fault that demands immediate attention. Fearing the worst for the PLC hardware, Ron swiftly navigates to the engineering station to investigate the fault description. To his surprise, the fault description reveals an issue with an array index. Ron, seasoned in PLC programming, knows that array organize similar data in a PLC program. For example, you could create an array to store motor run status of several motors. When you require an array member value, you can always reference it via its index number. He pinpoints the problem to the timer array index. Each element in this array holds a time value for amount of time that a mixer motor shall run in a particular phase of the process sequence. As Ron digs deeper, he discovers that phase variable is used as an index for this array. But this array is defined for 5 elements only, while the triggering index is a staggering 55 value. PLC have no way of knowing what to do in this case when array member 55 is called that doesn't exist. PLC opted for the safer option and halted the PLC operation. Ron feels that clock is ticking fast and he must find out quickly where this phase value of 55 came from. Then he realized that the phase value can be set by the operator at HMI and then transferred to PLC. He rushes to the operator station and a glance at it unveils the root cause. A simple typo. Instead of 5, the operator mistakenly typed 55 in the phase input. But this is strange. At this site, all inputs are validated at operator station before being transmitted to the PLC. If operator puts an out-of-bound value, the input should be rejected. So from where this 55 value came from? With a bit of investigation, Ron found that a recent HMI migration project mistakenly removed this validation. And now HMI is accepting any value for phase. Ron now knows the cause of the problem and made a plan to fix it. Question is whether Ron would be able to resolve this issue and save the day. He restores the validation in the HMI graphics by limiting the phase input to a range of 1 to 5. Determined to prevent such incidents in the future, Ron adds a limiter function directly in the PLC program. Now, the phase value will always undergo scrutiny at the PLC, even if issues arise at the operator station. After these updates, he resets the PLC and restarts the program. Everything is working normally now. With these corrective measures in place, Ron leaves the plant, satisfied that his quick thinking and expertise have averted a prolonged production loss.